Hello guys, so my name is Farhan. I'll be your instructor for Apache Solr course, and I have around 12 plus years of experience in IT field, and since last 8 years or something, I've been in Apache Lucene and Solr and handled more than 4 or 5 projects end to end. I mean implementations, configurations, and end to end usage of that for different platforms. Okay. So I believe this today is your second class, and I was waiting for you guys for yesterday class as well. So what I can say, maybe you can go through the LMS, and you can for the first class you can walk through the already recorded video of that class. Okay, that will help you in some sort. Okay, and if you have any questions regarding that, then do let me know. Okay guys. Yeah, I understand, Garfield. So which time zone you guys are in, Garfield and Alvin? Okay, Garfield in EST. Okay, Jamaica. Alvin same. Okay, Alvin is also in EST. Okay guys, so let me walk you through. So that was my introduction. So I would like to know a little bit introduction of you guys as well. So I'll unmute you guys for a while. Okay, Alvin, I am going to unmute you, so you can give your introductions. Just 1 minute introduction. That will be fine. Yeah.
Hi, morning. Yeah, so my name is Edureka, and I am a web application developer. I have 4 years experience in terms of e-commerce websites, where I use a technology called Edureka, which is similar to Solr. So my main purpose for this course is actually learning Solr in terms of being able to run an end-to-end project and do comparisons between that technology stack, Edureka, and Solr. That's my main purpose for this course.
Perfect. Thanks for your time, Alvin. Thank you. So, let me walk you through your LMS part as well. I mean, I believe you guys have access to your LMS. Yes, no? Now, and for the further communication, you can use your question window. Okay. So, this is your LMS. Okay. Which you can log into the provided credentials. Okay. And through this course, you can click on the course and go to your all the courses assigned to you for this particular course, which is Apache Solr. Okay, so I have a couple of courses here. So you have to go for the Apache Solr and click on the go to course. Now, when you landed on this page, you will see 3 tabs here: getting started, pre-recorded classes, and course content. So getting started will be all about your the details around the Apache Solr course. I mean the course which you have enrolled for, what we are going to do here. Okay, and basic requirements on software and hardware requirements to install Apache Lucene or Solr on your machine. Okay, so by clicking on these 2 links, you will get the PDF, which will provide you the insights how to install Apache Lucene or Solr in your machine. Okay. The next link is guide for your learning management system. So you can view this here, how to access your learning management system. You can do this offline as well. Okay. So this will give you the hands-on detail on your LMS, learning management system, provided by Edureka. Okay. Now comes to the pre-recorded classes. The second tab is all about pre-recorded classes. So module 1, we will be having module 8 modules in this class. So you will have all the recordings of modules available, which is pre-recorded classes, maybe even a month old, something, okay, which you can go through beforehand if you want, okay, or you can revisit whenever you want to this LMS, and you can view the pre-recorded classes, okay. The next tab is all about course content, which is the actual and the most important tab for your LMS for this particular course. So in the first link will guide you how to install Apache Solr, and it will provide you all the related documents how to which you can download, and you can go through it, and you can install your Apache Solr or Lucene in your machine. Okay, and then module wise you will get the details of what will be covering in this. Okay, so presentation, okay, the presentation which will be following, the quiz, the module lab. In this module lab, you can download this module lab and execute at your end. Okay, that will be the lab for you. Assignments, you can download those assignments and you have to complete this before the next class. Okay, similarly we have different documentations for Apache Lucene tutorial and the differences between Apache Lucene then and now. Okay, so this will be pretty much common across all the modules. Okay, so similarly in module 2 you will get the same thing, presentation, quiz, labs and everything. Okay, so this is all about your uh, content tab. Okay, how course content tab provide you the details. Okay, so as soon as your today's class will complete, okay, after 2 hour or 3 hour something, IT support team will be uploading the video of this class into this module, and you can even revisit the class as well, okay, which you are currently going. Okay, so this is all we have in LMS. Apart from that, we have a support or help desk for you guys, where you can access through this LMS as well. So clicking on support tab, you will get this window, okay, and you can select the appropriate course, let's say Apache Solr, and the particular category, let's say general discussion, project assignment, installations, or any kind of issues you are facing, and you can raise a ticket for it, and that ticket will be assigned to the support team and will be rerouted to me or someone else who is having the appropriate uh, command or the knowledge on that particular area. So if it is, let's say, if it is LMS issue, if it is a uh, LMS related issues or technical issues which you are facing to join the meetings, so if you are facing these kind of issues, you will be raising the ticket under non-technical issues or general discussion or project assignment depending on your needs. Okay, so if you have any issues related to Apache Solr or a particular subject, so you can raise the ticket as well. You can also raise the post a question into the forum, okay, so that other students or instructors can also take a look into that. Okay guys, any questions, any confusions so far? Perfect. So this will be your LMS, and you can access anytime throughout your courses. Even after completing your course, you can access the LMS. I mean, that is free. Okay, anytime you want, anytime you want to raise the questions, you can do that. Apart from that, you can, using LMS, you can also join your classes, okay, using this link. Okay guys, so this will be the 3 hours classes. I mean, each module will be 3 hours, and in between 3 hours, in the mid of that class, will be taking 10 to 15 minutes break, okay, and they will come back again in the class, okay, without leaving the webinar. Okay, so what will be the overall detail of the course? So first class was about introduction to Apache Lucene, okay. I mean, I'm not sure whether you guys are aware of, but Apache Lucene is a core API or the base API on which this search engine is built on top of it. Okay, so Apache Solr is actually using the libraries of Apache Lucene. So that's why the module 1 and module 2 about Apache Lucene, and from module through 3, which is next week onwards, will be covering the Apache Solr. Okay, so first two modules will be exploring Lucene APIs, what we have, what all the capabilities and functionalities we have in the Apache Lucene, and then we'll move on towards introduction to Apache Solr, how it works, how to install, how to configure, how to do indexing through Apache Solr, how to do searching, and then we'll move on to the extended features, most advanced feature of Apache Solr. And moving forward, we'll be seeing the Solr cloud administration of Apache Solr as well, and at the end we'll be doing the final project on that, and you will have to submit that project. So that will be the overall coverage of this course. Okay, so I believe both of you guys are in the e-commerce fields, and it's Solr is widely used in this particular business domain. So I hope that will be benefiting you guys in the long run. Okay, so today's module is about exploring more about Lucene. Okay, so objectives of this module will be, at the end you will be able to know, what is analyzers, querying, scoring, boosting, highlighting, faceting, grouping, joins, spatial search, Apache Tika, and we'll be doing the labs as well. So these basic things will be covered in this particular module. Okay, so last okay, so let me first so just one question to you guys. Are you guys using right now? You are using Apache Solr or Lucene right now, or you are intended to use in some future project? You have already started working. Garfield is using Solr on a basic personal project, Solr 5. Okay. Okay, Alvin is for a new project. So Alvin, at the end, I will show you the LMS where you can access the slides. Okay, so let me show you right away, I guess. So if you want to access the slide of module 1, you can just go through this LMS and click on the presentation, module 1 presentation view, and you will get this. Okay, so before that, I just want to know from you guys. Let me try to open this. Okay, I just want to go through 2-3 slides of module 1, so that just to set the uh, basic things. So so any languages exposure you guys have? Programming languages exposure, or which programming language exposure you have? Perfect. Alvin is having Java. Okay, perfect. Garfield. Java is okay. That's good. So though it is Apache Solr is provided under multiple categories of languages. Other than Java, it has support for .NET and then Python, Ruby, C hash, and multiple languages. But actually, Lucene APIs is built on Java only, and even the Solr APIs. So it is actually it will be what I would say. It will be a little bit. It will give edge to the Java developers actually. Okay. to understand it in a better way. So prerequisite for the course is, I mean, you have certain hardware and networking requirements fulfilled, like Windows, Mac, 4 GB RAM, 20 GB hard disk, gigs hard disk, internet connections. Okay, software requirements, Java knowledge. It will be good if you have intermediate knowledge of Java, Linux basics, computer science intermediate, and databases, engines basic. Okay, and a bit of technical skills you should have. That's it. Okay. So how it actually, I mean, Edureka works, it will be, basically your classes will be conducted by experienced instructor, I mean, who is actually working in the same field and in the industry itself. You'll be, you'll be facing or you'll be attending the live online classes, in class questions, survey feedbacks. You can access 24/7 supports, and you can even have your class recordings in LMS as well. Okay, and at the end of the day, at the end of the course, the project work and the verifiable certificate which you can use in your LinkedIn profile as well. Okay, perfect. So you guys must have familiar of this kind of a view, right? Search engines, right? So type ahead functionality, you're right, Alvin. That is a type ahead functionality. Okay, and similarly, we have a different other things as well. So first of all, what is the need of search engines? Why we need search engines? I mean, basically for the e-commerce websites, basically, what is the use and how it was being done? I mean, when we were not having, Apache Solr or Apache Lucene kind of libraries, how we were doing it earlier? Very simple questions to you guys. Any guesses, guys? Exactly. So Garfield is saying to allow users to quickly find what they want through search and refinements. Exactly. Alan saying it's what earlier it was hard to find what you were looking for. Exactly. So it was everything was DB driven. Okay. So the search was so and DB call was costly. Okay. Database calls was costly. All the data were in the databases, and database call was costly. So gradually, I mean, they start looking into the solutions, and they come up with this thing. Okay, and there is one guy who was actually uh, working on one of the libraries in CNET, and the guy name is Dog Cutting. Okay, who actually invented this. Okay, while working in one of the, this is the guy. Okay, he's the creator of Apache Lucene. Okay, perfect. So I just wanted to let you guys know, I mean, the um basic features of Apache Lucene from the module 1, like indexing and searching, ranked searching, many powerful query types, phrase queries, wildcard queries, proximity, field searching, okay, sorting by the field, multiple search indexes, searching, okay, flexible faceting, highlighting, joins and results and grouping. So these are the basic key features of Lucene. Okay. So I just wanted to little bit touch base with the module 1, and rest you guys can access your recorded class. Okay, so Alvin is saying he went through a pre-recorded class on module, so you guys are good, fine. So let's move ahead, I mean, with module 2. Okay, so let's do the little bit recall from the module 1. Okay, what was discussed earlier was Lucene is a powerful Java search library that lets you easily add search or information retrieval to applications. Indexing and searching, ranked based searching, phrase queries, wildcard queries, proximity queries, range queries, and many more type of queries we have. Okay, So like in the RDBMS, we don't have a global common schema. Okay, Lucene has indexes which contains documents. Each document can have multiple fields. Okay, and each document can have different fields for every document. Okay, it's not necessary that you are creating a documents for a publisher, let's say books. Okay, where book ID, book author name, publisher name, title, and price, and whatever, right? So you can have a different set of fields for a same set of documents, right? So even you can add VAT or any other kind of a taxes or any other kind of a fields in that as well. Okay, so that gives the flexibility of schema in while defining or while working with Lucene or Solr. Okay, perfect. So far so good, guys. Shall we move? Perfect. So analyzers in Lucene, what it does. So actually analyzers handle the job of analyzing the input text or the text which is provided for indexing, and directs into the tokens or keywords to be searched or indexed. Okay, analyzer builds a token streams which analyze text and represents a particular policy or put certain kind of algorithms, okay, for extracting index terms from that particular text. Okay, there are few default analyzers provided by Lucene which can be used at the time of indexing or querying. Okay, I will show you some of the classes or the analyzers which has been used. Okay, so analyzers are provided to parse and analyze different kind of languages as well. So that is I-18N is by default it is supported. So any kind of a languages you want to use, like Chinese, Japanese, Spanish, French, English, any other language you want, any languages you want, you can use here, and you can analyze it and parse it and create a different tokens on the basis of analyzers. Okay, so this is basically analyzers for you guys. So these are some of the Lucene classes provided by your Lucene API, which does all the work of analyzers. Okay, which does all the analysis works like Chinese analyzers, analyzers, Shingle analyzer, simple analyzer, smart Chinese analyzer. So many analyzers. So basically we use standard analyzers and simple analyzers. Okay, we have stop analyzers. Stop analyzers is all about filtering out all the stop words which you don't want to index or store. Okay, white space analyzers. So white space analyzers is like while indexing your text, saving it somewhere, it's remove all the white spaces to minimize the memory footprint in your while creating the indexes. Okay, lowercase filters, Porter stem filter. Lowercase filters will lowercase all the text which is input or inserted into the indexes. Okay, Porter stem filter is used for stemming purpose, which I will show you as with an example. Okay, any questions, guys, so far? Perfect. So analyzers, we'll be covering some of the analyzers here in the class, like simple analyzers. Okay, you guys can, before going to the text, you guys can see the diagram here, funnel diagram here. Here in the text is like in 2014 comma Edureka. Okay, it's going to this particular analyzer, which is simple analyzer, as a funnel. Okay, so what it is doing, it's filtering out all non-letter characters. Then it's filtering out all the numeric characters. Okay, and after that it's putting letter tokenizers, or you can say with the lowercase filters. Okay, it's putting the filters to lowercase. So you guys can see the output string here. So it will be, of course, non-letter characters will not be there, like exclamation signs and commas should not be there. So in an Edureka only should be the output of this particular funnel. Okay, and how to use it in the class, Java class? You can say create analyzers, say new simple analyzers, and provide the version, and then in the index writer config pass that particular analyzers, and you can write the indexes or create the indexes out of it. Okay, so cut short, in short, what I would say, it's simple analyzers filters all the non-letter characters, okay, all the numerics, and then convert into the lowercase. So that is the work of simple analyzers. Clear, guys? Perfect. Stop analyzers. Again, stop analyzers will take all the input text, filter out all the non-letter characters like exclamations, comma, or anything else. It filter out all the stop words, okay, and then the numeric characters. So the difference here is stop words. Okay, stop words can be anything, like in the all the prepositions which you don't want to search. Usually user don't search with these kind of things, right? So don't want to do searches on that. So just to minimize the storage capacity, or your using your memory wisely, so then you can use stop filters, and you can stop analyzer, and you can remove all the unnecessary words which you don't want to be indexed. Okay, so this is the work of your stop analyzers. Okay, so these stop analyzers words or stop filters words, you can either provide in your configurations, or either provide in your class, or even you can provide the file .txt stopword.txt file as a configurations, and it will, and you can provide all the stop words in that particular file, and that will filtered during the indexing. I will show you the configurations as well, how to do that. Okay, now standard analyzers. Okay, so there is a question from Alvin. So question is, if you have a title for a book called The Ring, and the stop analyzers removes the, what are the ways to bypass? Okay, fine. uh, so that's the main thing actually which you need to know during the indexing. Okay, so if you don't want to filters, okay, if you don't want to filter something from the title or from something somewhere else, just don't put that condition on that particular field. So skip that field. Okay, so let's say field is a title. Okay, and usually, I mean, what happens usually, let me give you one example. Okay, so let me give you one small example. Okay, maybe the same book example what I will like to show you, so that is the better way. So let's say this is the book. Okay, now, and we have different fields in the book, or title, author, price. Now we have another fields, let's say description. Okay, okay. So I want blah blah, okay, whatever, on a whatever, right? Now what I will do, so I usually title is like you want to be searched as a one, okay, or maybe again that is another thing. So there is two type of analyzers, okay, one during the indexing and one during the querying. So you have to take care of both, okay. So while indexing, you don't want to, let's say, the ring or the hobbit or any other, programming in Java. Okay, you don't want to remove this. Okay, you can go ahead and don't index and don't use that particular stop filters or stop analyzer that for that particular field. Okay, if you want your title should be indexed as is. Okay, if you want your title to it should be indexed as is, then you avoid using stop analyzers or these kind of a things, stop filters kind of a thing. Okay, clear, Alvin? So that is how you actually design the schema. So when I will be covering this thing in a Apache Solr, then you will understand it in a better way, right? So there actually, even after using standard analyzers, you can pick and choose the filters as well. You can remove the stop filters from there. Okay, so you can even use your own analyzers. Let's say my analyzers. Okay, you can create your own analyzers. If you're a Java guy, you know how to write code. You can even create your own analyzers as well by extending the analyzer. Perfect. So standard analyzers. Standard analyzers is all about filtering the punctuations, stop words, and then standard tokenizers. What standard tokenizer do? It with standard filters, lowercase filters, and stop filter. Okay, so these three filters will be applied while you are using standard tokenizer. Okay, standard filters, lowercase filters, and stop filters. And at the end, you will get only Edureka. Okay, so just remember, guys, there are only two things. There are two things. Indexing is different thing, and storing all the text is different thing. Okay, so it's similarly it works on the same principle. I mean, how it works in a database as well. So indexing is done just for the faster retrieval. Okay, and if you guys aware of the reverted indexing techniques, then Apache Lucene or Solr is built on top of reverted indexing techniques. Okay, you guys are aware of reverted indexing techniques? Okay, so Garfield is saying no. Alvin, reverted indexing? Let me quickly give you one example, so uh, that will help you to understand it in a better way. Okay, so best example of reverted indexing technique is books. Okay, in your front pages of your book you will see indexes. Okay, indexes like chapter 1, chapter 2, or whatever, right? That is indexes. But when you go at the end of the book, your last pages, you will see some of the indexings as well. Like for an example, you are going through some Herbert Shield book for complete reference Java, right? So if you go at the end of that particular book, you will see that it will give you that Java or swings appear on this page. Have you guys seen that ever at the end of the book? So let's say, for example, if you want to quickly want to know, I mean, where is swing? Okay, where is some specific thing? Let's say where is threads? Where is array list? Okay, so you will see array list is appears on this page, page number 15, page number 18, and page number 24. Okay, so using those indexes, reverted indexes. So those indexes are known as reverted indexes. So using those reverted indexes, you can easily scan your books or easily scan the information you are looking for. Okay, guys. So that is the best example of reverted indexing. So let me show you the pic of that as well. So this is how your reverted indexing works in uh, inverted index, I would say inverted index. Okay, so this is how your inverted index work or in your Apache Solr or Apache Lucene. So let's say you have this document 1, document 2 and document 3. Okay, and now you are indexing it, and there is one stop word list which is filtering all the stop words. Now you can see id is 1, best is term is best, and it is available on document 2. id is 2, term is blue, and it is available on document 1 and document 3. So you guys can easily identify that. I mean, if you are somebody is looking for butterfly or somebody is looking for sky, okay, that particular guy can easily scan the documents and he can easily reach to that particular content. Okay, so that is the base of your Lucene API or Apache Solr, on which inverted indexing techniques built on. Exactly, you're right, Alvin. So it's basically give you the document, but when we progress towards more advanced classes, I will show you how to do field-based searching as well. So if you want to do field-based searching, say you have multiple fields, title, author, or name or price. So how to do that field-based searching as well. So rather than looking on all the document fields, it will specifically look into that particular field. Okay. Any questions, guys, so far? Stemmer or stemming or Porter stem filter, whatever you can say. Okay, so what is stemmers and how it works? Okay, so stemmers are used to get the base of a word in a question. It heavily depends on the language you used. Okay, so if you're using English, that should be specific to English, or any other language, then that should be particularly for that specific language. So that is dependent on language, which language you are using. Okay, for example, if you want to identify the string cats, okay, so you cannot force or you cannot ask user to search only for cat or cats. Okay, so anyone looking for cat like catty or something like that, or swim or swimming or swimmers. So these kind of places where we go for stemmers or stemming. Okay, we use some stem word, and then the root word will be like cat, and then you can search for cats, cat like, or catty. That is heavily dependent on your language. Okay, so that is resolved through the inbuilt dictionary provided by Lucene or Apache Solr. Okay, on you can also add up onto that as well. Okay, so root word is swim. Okay, but end user is searching for swimming or swimmers. Okay, so how to do that? Okay, so these are the scenarios like fish, fishing, fished, fisher. Okay, so those are some similar words, I would say. You want to stem with fish. Okay, so then you can search for fishing, then even then you can find fish and fished and fisher. If you search for fished, then you can also find fish, fishing, fisher. So likewise. Okay, so understood, guys. Stemmer. Perfect. So this is the example in Lucene. Actually, this is something in the example in the lab. It is hard coded, or you can say it's written in the Java file, finished, completed. If somebody is looking for finish, it will also look for finished, completed, and then finished, over, finished, ended, work, job, work, labor, work, effort. You can bind it, okay, together. But in your Apache Solr configuration, it's all about simple, just configurational tweak, nothing more than that. So for an example, if the root word is work, so somebody is searching for labor, job, or effort, then it should also be provide the results. Okay, so similarly goes for finished. Finished is equivalent of completed, over, or ended, or any other thing. Okay, which is related to your language. So this is how your synonym works. Okay, so adding synonyms at the same token position, or you can use synonyms.txt as well. Okay, so that is the difference between stemmers and synonyms. Perfect. So let's see some of the labs. Okay, then it will give you a better idea how it is actually working. So I have shown you guys, when you download the lab, it will download it at something like this as a zip file. Okay, unzip it and you will get all the related labs: lab 1, lab 2, lab 3, lab 4, lab 5. Okay, so now see the lab 1. Okay, so first of all, first thing first, let me show you the configuration here. So first of all, see which Java version I am working on right now. So I am working Java 1.6. I have other version as well. So it you should use 1.6, 6 and above, JDK 6 and above. Okay, make sure that you have JDK 6 and above. Right. Now let's go through the labs as well. Standard versus simple analyzers. So let's go inside M2 lab 1 first. Okay. Okay. You guys can see my screen, right? Perfect. So let me delete the indexes here. Okay. I would like to generate it again. Okay. Now it's saying delete the indexes folder if exist. I deleted it. Now copy paste this and execute it. So since you guys are a Java people, so let me explain you the command. Okay. So Java -c is looking for the class path libraries, which is nothing but your Apache Lucene libraries here, sitting here, this jar. Okay. And then it is saying m1 lab1 dot index files. So m1 lab1 jar file, when you open this jar file, okay, you will see labs, okay, index files and search files dot class. So it's looking for this particular class files, okay, index files. Then it's saying hyphen index folders hyphen docs dot documents folder. What it is doing, it's reading for these from these document files, txt files. Okay, these three txt files, is it's taking these txt file as a raw documents or raw content. Okay, and then it will create the indexes in this folder. Okay guys, let me do that. Okay, so now it's saying unsupported class version error, and so it's giving me this error because right now I am the classes file is created on with the major version like JDK 7, and I am executing it with JDK 6. So let me go through with JDK 7. Okay, and what I can do here, I will go here and I will say this, and I will use JDK 7 to execute this. Okay, so make sure you have JDK 7 and above installed here. Okay, so now I don't have any indexes right now. Let me use this and create the indexes. You guys following me, right? And if needed, you can also revisit the videos. Okay, if you miss anything, or you can ask me the questions. So now it's taking, now it's indexing. It's see, if you guys can see my screen, you can see that it's adding these three documents or indexing the documents and creating the indexes. Now you can see indexes being created here. Okay, see these indexes. Okay guys, so now this index is being created here. Okay, now I'll search the index using standard analyzers. Okay, how to do this? Maybe for a quick thing, what I can do right now, let me quickly change the JDK so that I don't need to keep adding this string to. I'm just changing the Java home to JDK 7 so that I don't need to, I guess. Okay, perfect. Perfect. Now I have Java 7. Let me go to the lab again, more time. Now I don't need to change the Java version again. Okay, so I just need to copy paste it, command. Okay. Okay, so now I am going to search the files. Now it's asking me to enter the query. Okay, so what's the question, Alvin? So which resources you are trying to download, Alvin? Okay, you are trying to download the module 2 labs, right? Okay, so you can download it anytime you want, right? So what you can do right now, you can just follow the class, because this class will be is getting recorded and you will see this again. Okay, so in that case you can cover it up, but if you miss it right now, then it won't be that much interactive for you, right? So I'm just going through it, just follow that. Okay, maybe after the class offline you can download it. Okay, or maybe for the next classes you can download it beforehand if you want to do the parallel execution as well. Okay, so otherwise maybe you will miss something in between. Okay, so now I have already indexed these three documents. Let me open the document for you guys. Okay, this is the document. Okay, let me select it and put it in the notepad. Okay, this is file 1. In Edureka provides big data Hadoop training courses, bad word. File 2, in Edureka provides also big data NoSQL Apache Cassandra training courses. Okay, in 2013 Edureka Y2K problem. Okay, so these three files being indexed. Okay guys, now I have used the standard analyzer to index it, and also using the standard analyzer to search it. Okay, now I am going to search for the Edureka. I'm going to write Edureka and search it. So any guesses, guys? How many results I will get? How many documents I should get? Exactly, Gafil. 3 documents, because Edureka is in all 3 documents. Okay, perfect. Now I am looking for 2013. Okay, it should be in 2 documents. Okay, file 3 and file 2. Actually, I have changed the things. In file 3 I have 2013, in file 2 I have the 2013. Okay, so no issues because I have changed it, so not a problem. So just to let you guys know, now I'm going to use simple analyzer to create the indexes. Okay, so for that I need to delete the index first. Okay, let me delete the index. Now I'm going to create the index with simple analyzers. Okay, this was standard analyzers, and a standard analyzer doesn't filter your numericals values or numerics. So now if you see, I have indexed it again with different indexer or analyzer, sorry. Okay, now let me do the searching again with simple analyzer. Okay, now I am looking for Edureka again, and I will get again 3 documents. Any guesses if I go for 2013, what should I get? Garfield saying none. Exactly. Alvin, you there? So I am not getting any data for 2013. Reason? What happened behind the scene? Any guesses? Exactly. All the numeric characters being stripped off based on the analyzers. Exactly. So that is simple analyzers versus standard analyzers for you guys. Okay. That was lab 1. Any questions from the lab 1, guys? Perfect. So let's move ahead. Lucene querying. So we have seen okay, let me see some more labs as well. I guess we have some other analyzers as well. Let me check. Yes, stop words. You guys want to see stop analyzers? How actually stop analyzer works? Perfect. So let's go ahead and check the M2 lab 2. So let's go into M2 lab 2. Okay. Delete the index field, index files here. Okay, and create the indexes using index documents. Okay, here paste. So it's indexing it. We have 2 files. The document field, it's created the index. Okay, file 1. Okay, and see here, one word is bad word is rascal, bad word. So we have this, and then in file 2 we have idiot as a bad word. And you guys see here we have stop words.txt. Okay, in stop words txt we have some stop words mentioned here: idiot, bad word, rascal, hadoop. I mean, these are the we have added some bad words here. Okay, guys. Okay, that should not be an issue, Alvin. Okay, Java is platform independent. Okay, you can run it whichever platform you want. Okay, I'm using Windows. You can use Linux, Mac, whatever you want. Okay. You just need to make sure that you have JVM installed there, 7 and above. Perfect. So let's do the searching. Now I am going to search something. Okay. Now I am going to search, let's say Edureka. Okay, Edureka is in 2 documents. Let's say 2013. 2013 is not there. Okay. No. 2014. No. Now, if you guys can see, I am going to search for some bad words. Okay. Let's say idiot. If you see, I am getting 1 document. Okay. Okay. Because we have used we have created the indexes using simple analyzers. Okay. After that, do you have any question, Garfield? Please go ahead. So meanwhile you write, let me explain you this, guys. So you guys can see even I am able to search bad words as well, right? Idiot, rascal, or Hadoop. Okay, because reason is this: I have used simple analyzers to index the file. Now I am going to use stop analyzers to index it. So what I will do, I will recreate the indexes. Okay, so I will come to your question. I will come to your question, Garfield and Arvin. Let me complete the stop analyzer, then I will come back to your question. Now I am going to create the indexes with stop analyzers just to show you the example of stop analyzers. Indexes being created here. Now let me search the files. See, file 1 and file 2 I am getting. 2013, 2013 is not there. 2014, no, it's not there. 2015, no, it's not there. I am going to search for the bad word. So it's not giving me bad words because it is filtering out all the bad words. See, hey guys, how it is filtering out the bad words? You can see that stop as an stop word filters. Now, let me take care of your questions. Okay, Garfield saying, I noticed when you searched for Edureka, it listed the files 2 and then file 1. But in the file system, the file 1 was first. Is there a predefined sort being applied? Okay, nothing as such right now. Will be concentrating. If you see in the file system, you can say file 1, file 2 is like that. But if you sort it, then file 2 and file 1 become something like this. If you sort on date modified, it will sort on accordingly. Okay. So displaying while you are querying, okay, indexing is a different thing. And then after searching on top of indexes and fetching the results and displaying it, it's a different thing altogether, Garfield. Okay. So we have a different APIs and options or functional modules to overcome that. Okay, we have many other things as well which we'll be covering in Solar as well in a detail. Okay, you can do n number of sortings, you can do n number of other business logics kind of a thing. on top of the returned result sets or returned documents. Okay, even you can analyze the written documents as well, okay, during the query. Okay, so many things we have. Okay, so right now it's a very basic thing how Lucene is working. Now comes to the question, Alvin's question, right? Can you apply more than one analyzer at a time? Yes, you can do that. Multiple filters, you have to make sure that you should be using the same analyzers for indexing and same analyzers for searching. Okay, otherwise you will get the data mismatch. Okay, the analyzers which you are using for the indexing, the same analyzer should be used for searching. You just need to make sure that. Okay, Alvin. So analyzers is a class. You guys are a Java guy. Let me tell you very straightforward. Analyzer is nothing, not a big thing. It's a simple Java class which do certain business logic or certain processing. And in that Java class, you can have multiple filters, okay, and multiple tokenizers, okay. Then tokenizers and filters in another Java classes, okay. So then again, so it's giving you flexibility to mold your analyzers. Okay, you can have multiple filters or more than one filters or more than one tokenizer in your one single analyzers. Analyzers can have one tokenizers or more than one, or one filter or more than one filter. Okay, during indexing and during searching both. Clear, guys? So this was upward example for you. Okay, let's see what we have in its lab tree. Okay, stemming. Let me show you. Do you guys want to go through this lab as well? Stemming example. Perfect. So let's go to the lab tree. Fine. Let's delete the index first. Okay. It's saying create a new document, file3.txt in documents folder with following content. Okay. So in document folders, I have already created file3.txt, which is saying fishing, fished, fisher, swimming, swimmers, stemmer, stemming, stemmed, walking, walks, friendly, friendliness. Okay. Now in file 1 I have something else and file 2 something else. So forget about that right now. Let's create a indexes first. So it's being indexed, file 3 being indexed. Now search it. So you guys have seen here that in the documents tab I don't have anything something like called fish, right, in any of the documents. If you see here, in any of the documents we don't have fish, right? But I am going to try and search for a fish. What it's saying, I have matching document in file3.txt because it is using stemmer. Okay. Similarly, if I go and look for swim, I will get another the same documents again because swimmers are there. Okay. And when I go and search for friend, it will, okay. If I am going for friend, let me see. It's not giving me any documents because friendly and friendliness is not the stemming words in English language for friend. Okay, so if I go for walk, then I will get the documents because walking and walks is a stem word for walk. Okay guys, clear? Perfect. So that was stemming for you guys. I just want you guys to do some labs as well by yourself. So maybe lab 4 is about synonyms. So I would ask you guys to go ahead and use synonyms analyzers at your as an homework. Okay, and let me know if you stuck somewhere. Okay. Okay. So there is two question. Alvin is saying, could you go over why friend did not work? So friend is not a stemmer or stemming word for friendliness or friendly. Okay. Maybe if I have put friends, then I would be able to search for friend. Okay, Alvin, that was the reason. So I was having some success case as well and one failure case as well, where you won't be able to search if that is not a stemming word for you. So there is the question Garfield is asking that is related to what you ask. Garfield is asking the Lucene API is using a default English dictionary. Yes, Lucene API is using a default English dictionary. That's why it's actually doing it by itself. I just need to provide all the stemming words, okay, and I can search it. So just index all those things and you will be able, by default, you will be able to search it. Okay, perfect. So let's move on and see some querying thing. Perfect. Querying. Querying key types or classes. So these are the classes which is used for querying purpose. Term query, Boolean query, wildcard query, phrase query, prefix query, multi-phrase query, fuzzy query, regex query, term range query, numeric range query, constant score query, disjunction max query, match all docs query. So I will be explaining some of the queries one by one to you. So don't worry. So these are the classes we will be using for querying purpose or searching purpose, I would say. While searching, you have to use these different classes, query classes. Term query. So the most basic way of searching is using a term, which is known as term query. So term is the smallest index element, consisting of a field name and a text value pair. Okay, where you can say title is equal to the ring, Hobbit, or Lord of the Rings, or any titles you want, right? So it's like that. Term query are especially useful for retrieving documents by a key, okay, or by a field name, okay, or specifically you are looking for certain term, one single term like New York. So New and York are not two different things. New York, you want to search New York, that you should look for the New York as a single term, okay. All documents that have the word Edureka in a name field are written from such query term using term query. So if you see here two line of code, term is equal to, okay, okay Garfield, no issues. So if you guys can see here, term is equal to new term name Edureka, okay, and query is equal to new term query, and then you can search it for. So what exactly it is doing, Alvin? Any idea? This two line of code. Alvin, you there? Alvin, you can hear me? Alvin, okay. Yes, actually, I mean, to be more precise and specific, it's actually looking into the field name, okay? Field is equal to name and it's Edureka. So let me show you the way it is actually looking. So it will be stored somewhere in the index like this, name, okay, Edureka, something like that. Exactly, name value pair. Okay, so you can something you can when you use Solr, you will say something like this: select, okay, like this, q is equal to name colon Edureka. Exactly, name is the field and Edureka is the value. Term range query. Term Terms are stored in the sorted lexical order, and a query that matches documents within a range of terms are written using term range query. The beginning and ending terms may either be included or excluded. It's not intended for numerical range only. It can work for text as well. Okay, so even you go for a numerical range as well, or you can go for text range as well. For an example, all the names which is started with A and D, okay, should be returned. So all the matching document will be returned, and the last two parameters true will say that including and inclusive or not tag. So A to D, A B C D, all the names stored with A B C and D will be returned as a set of documents. So this is how your term range query work. Shall I move, Alan? Or you have any questions? Okay, thanks. Numerical range query or numeric range query, you can say. Numeric range query is, I mean, whatever we have seen in a database, more or less you will see the similar thing here in the Lucene and Solr, but it will be little bit faster and it will be a little bit unstructured schema, which or a flexible schema, you can say. So numerical range queries, where you can say all the employees join in the year 2009, in between the year 2009 and 2014, written all the documents. So joining date, okay, or age or salary, okay. So this is numerical range query, how it works, okay. It will return all the documents. So in terms of e-commerce, this how it works, okay. When you filtered the products on the basis of price, so you want all the Samsung phone with the range of 1500k, 1500 bucks to 200 2000 bucks, right? So this is how your filtering works in e-commerce as well, okay, on different fields. Prefix query. Prefix query matches documents containing terms beginning with a specified string. Can be used to find all the documents under a tree. So if you guys digging into the tree kind of a structure, okay, okay, if you are going through the some predefined tree structures, then you can go for it. Like you are searching on the basis of some departments or some, you know, business. Like if you guys have seen in the e-commerce website, right, it's like electronics, okay, apparels, okay, and under electronics it is electronics, and then it is kitchen appliances, and then or maybe, I mean, what I can say, multiple things you can see here, right? So that is actually happens through your prefix query, okay, so that you can create a tree kind of history. So okay, you are asking some question, Alvin. The ranges, can you predefine the ranges while doing the analyzer, or do you have to do the ranges during the query time? Okay, okay. Analyzers basically use for, I mean, for both indexing and searching purpose both, but ranges is related to querying, okay, while doing the searches. you have already data indexed and stored in your file system. Now you are accessing it through some APIs or some queries. So those APIs are nothing but some classes, okay, and using those classes you are accessing the documents, okay. So it's actually it's a design standards, best design standards, I would say, that you should index or store all the documents and then put ranges, okay. So we can do that what you are asking, but it will happen when we have specific business requirements or specific infrastructure requirement. Let's say you have a huge data sets, okay. You have a data sets in a terabytes or some more than that, right? So then you would like to bifurcate the documents through analyzers, and you can store all the employee with the name starting from A to M should be here, and then M to here should be here, like this. Then you can do that in that case, okay. But basically ranges applied during the query time, okay. Wildcard query. Wildcard query pretty much similar what we have seen in uh, database as well, okay, but a little bit different. So supported wildcards are star, okay, question mark, and backslash escape characters, okay, which matches any star matches any character sequence including the empty one, okay. So A star M, okay, or B star T, okay. So bat, but whatever you want to search, it will go like that. And number of characters can be in between in place of a star. And when you go for question mark, so question mark is matches any single character, okay. You can only replace question mark with one single character, okay. And backslash is used for the escape character. In Lucene, we have this limitation that wildcard term should not start with star, okay. So you cannot say employee where employee name is equal to star xyz, okay. So you cannot prefix star in wildcard in Lucene APIs, okay. So that should come as a postfix or in the middle of the term. Clear? Wildcard query clear? Phase query or phrase query, I would say. Phrase query can be used to query for a sequence of terms where the terms do not necessarily have to be the next to each other or in order. The phrase query's object setSlop method can be used to set how many words can be between the various words in the query phrase. So when you say hamburger steak and you set slop 3, so in between hamburger and steak you can have 3 or less than 3 words, then you will be able to search it. So that is the meaning of slop, okay. This many slop you can have in between two provided terms in the phrase query, okay. Let me show you one of the example here. Okay, thanks Garfield. So couple of type of queries we have covered so far, 2 or 3, not big one: wildcards, prefix, and numeric range query, okay? So I am talking about phrase query right now and term query, right? So I'm talking about phrase query now, where phrase query is used to query for a sequence of terms, okay, where the terms do not necessarily have to be the next to each other or in order, okay. So the phrase query object setSlop method can be used to set how many words you can have between 2 or 3 more than 2 words, okay, in that the given particular query phrase. So let me show you one of the example. Okay, let's say hamburger So this is one of the example. Okay. S1, let's say S1 string 1 is hamburger, string 2 is steak, slop is 3. So I am saying document 1, let's say field 1 is saying I love steak hamburger. I am saying hamburger contains lots of cheese and steak. Okay. Third is saying hamburger has lots of steak. It's there is no sequence, Alvin. Okay, there is no sequence as such. Okay, so it's only phrase. Okay? You can it's phrase and how many? Okay, question is Garfield asking question. Does this apply the analyzers first? Okay, so right now I am talking only about query. Everything is indexed through analyzers. Okay, it's stored somewhere in the file system. Now I am using different type of a query scheme or a classes to fetch the documents. So forget about, I mean, right now I'm just giving you example here. Forget about any stop words or prepositions or anything. I just count it, everything count as a word. Okay. So can you guys tell me, I mean, what, oh, yes, no kind of a thing here. So as per this, so I'm just for an example, I mean, Garfield. So if you put stop words, if you want to filter I and off, you can do that. But this is an example. I'm just trying to show you the example. Okay. So okay. So Garfield is saying ST1, you will get the document. Okay. Yes. How about this, Alvin? How about this document? Will you get it or not? Use the using the query. Okay. So Alan's not sure. So hamburger steak. Hamburger steak 2 string, and we can have 3 slops or words in between those two. Okay, maximum 3, greater less than and equal to 3. You will get it or not? Exactly, it will not work. How about this? No, just forget about stop words right now. So now what about 3? Exactly. So this is the example of your trace query. So this is the way it works in Lucene, and I will show you how it works in uh, Solr, while we'll covering the Solr as well. Okay, in the classes. Querying, Boolean query. Boolean query is a straightforward one. Okay, where you can use and or kind of operator, and or not. Okay, logical operators. Okay, to form your queries. Okay, so for an example, you can add all the terms like mushrooms and steak. Okay, so and say boolean query dot add query one boolean cross dot occur must. Okay, occur must not. So these kind of a thing you can use in boolean query. Even in Solr, it's a pretty straightforward. You can directly use and or and not combinations. Okay, so let me see whether I have this in here. So let me show you in the lab about this. Okay, this is how your Boolean query works, and query parser or Q parser, you can say. in Solr. Here it is a query parser. In a Solr, it's a queue parser. Okay. Although Lucene provides the ability to create your own queries through its API. Okay. You can create your own query, which you have seen, right? It also provides a rich query language through a query parser, a lexer, which interprets a string into a Lucene query using Java compiler. Okay. Query parser tries to detect the syntax and type of the query and produces appropriate types implicitly without even asking you to provide. Okay. For an example, date colon x to y produces a range query that searches for date fields between this x and y date. Okay. Similar goes for name query. Okay. Name colon Abram or Lincoln. Okay. So like this. Okay. So this is implicitly supported by Lucene query language. Okay. And the query parser is a lexer. Okay. So using that you can form your query as well directly. So you can see some of the examples here like index searcher, new index searcher, index directory, query parser, then query parser which field. Okay. And then using query parser dot parse you can provide name colon Edureka or name colon brain for s. Okay. Clear guys? So far clear? Perfect. Okay. So let's talk about query syntax. Okay. A query is broken up into a terms and operators, which is known as term. There are two type of terms, single terms and phrases. Okay, single terms are like test, hello, Edureka, or anything, author name or whatever. I mean, single word you can say. A phrase can be a group of words surrounded by double quotes, such as hello Dolly, New York, New Delhi, or anywhere else. Okay. So multiple terms can be combined together with Boolean operators to form a more complex query. Something like this. Okay. Where you can say title is equal to the ring or the hobbit. Okay. Then give it to me. Give the related documents. So this way you can form the query as well. And even you can put the wildcard searches in with title colon R star T or whatever. Okay. So some what we have seen so far in databases, most of it supported here as well. I mean, in terms of query, okay, you can query with the simple one as well, and you can even form the most complex form of query as well with the help of different keywords and options or algorithms provided. So range searches where you can say age colon 35 to 45, or you can say salary colon 15k to 16k. Okay, you can use Boolean operators with the directly with the queries as well. Let's say the Jakarta Apache, Jakarta Apache or Jakarta. Okay, you can use and or plus together or not as minus. Okay, and or plus slash plus is the same thing, and not and minus is the same thing. Okay, you can use this interchangeably. You can even use regular expressions as well with the slashes, with forward slashes. Okay, also supports features like grouping, fuzzy queries, proximity searches, boosting terms, and many more, which you'll be seeing, which will be going through very soon. Okay, in the labs as well. Let me see what we have in the lab. So any questions guys so far? Any questions? Okay, perfect. I did not catch the last question. Okay, okay, got it.
Okay, let's see labs. Lab 5. What is in lab 5? Term query. Okay, term query example. Let's see the term query example. First of all, delete the indexes. Okay, go to the M2 lab 5. Okay, create the indexes. Okay, okay. I'll come to your question, Alvin, after this lab. Okay, perfect. Now check this example. I have executed java-cp lib and then this class Lucene term query demo and searching for apples. So it's saying apples. It's looking for apples in this file 2 and file 3. Let me check its validity. It's saying in file 2 and 3 we have apples. Let me check. Yes, we have apples. Right? In file 3 we have apples. Okay? This is what? This is the example of term query. Okay? Now I am going to do the same for apples. I did the search with apples. Okay? You guys can see that? Now I am going to do the search with apple. Okay? Just see I am enclosing the term, or I have surrounded the term with double quotes. Okay? Now I am looking for apple. I am not getting any data. So this is one of the example of term query. So which will specifically look for that particular word. If you change anything, you will not get any word out of it or any documents out of it. Clear, guys? Okay. So let's go for test 3. Okay. I'm looking for 2012. I'm searching it. It's saying only there is one document found, that is file5.txt. Let's see. Yes, we have 2012 in this. Perfect. Now what? I am looking for French fries. Okay. I'm not getting any data because French fries is not available. Now I will look for French only. Now I'm getting 4 hits. File 1, 2, 4 and 3. Okay. French I have. Okay. French I have. Okay. And even if you guys can see, French fries is a 2 words, but I am not getting it because I am using this. Exactly. It's a phrase, not a term. So that is the difference. Okay. So if you see here, this is not a single term, and we have done as we are looking for as a term only and not as a phrase. So for you guys, let me show you the class file as well here. Okay. This is the class file which is being used, and you can download it from your lab as well, and using your ID you can check it. Okay. See, now that is the reason. If you guys see here, in this particular class we are using term query as a class. That's why it's looking only for single term, not for the phrases. Okay, clear? Perfect. Now go ahead, and I'll be using some parser. Okay, so this class is written long back actually. Okay, and it's already a part of your LMS. Okay, some of the classes I have already written, and some of the classes I'll be sharing with you guys as well. No, this is not built in as a package. This is a part of Edureka. Okay, so we're written by instructors. Okay, when you download the uh, lab, you will see something this Apache Lucene as well. In Apache Lucene, you will get all the all the Java files here like this. Okay, all the classes you will get. Okay, and if you good in Maven projects, the project is created using Maven, Apache Maven. Okay, it will be easy to configure it in your Eclipse IDE as a Maven project. Simply configure it as a Maven project. Maybe if you guys will be interested, maybe in the next class I will show you how to configure it as a project as well in your Eclipse. Okay, so that you can even run it from here as a Java class. Okay, perfect. So there I was. Okay, let's see some example of query parser approach. Let's clean the screen, then say contents is equal to apples. Now I'm getting file 2 and file 3. Now I'm saying apple. No, it's. Now I'm saying apple star. What will happen? Anybody? Let's see. I'm getting the data. Is it? Why? Because I have used wildcard. No, this is a wildcard. If you put star, you will get the data, right? It's a wildcard search. Okay, I have provided the wildcard query as well. Okay, just go ahead and try your hands as well. Okay, then maybe you will be able to understand it in a better way. No, I am not using term search. It is a query parser. So the approach I am using is query parser demo. Okay, so in query parser you can use the name and name value pair. Okay, you can provide the field and then provide the value. Okay, okay. Sorry for that. I mean, maybe I did it bit fast, I guess. Okay, guys. Perfect. So best thing is that go ahead and try your hands in it. Okay, try different permutation combinations, play around with it. Then you may get it more. Okay. Boolean querying. Boolean querying. I said occur must, occur should, occur must not. Okay, occur must signifies that term should occur. Must. Should means optional. Must not is not. I mean, should not occur. Okay. Let's see some example. M2 left 5, right? Lucene Boolean query demo. When you say query, plus contents is equal to mushrooms plus contents is equal to steak. Okay. So it should return where when there is a mushroom and steak both. Okay. You guys can see my screen clearly. Perfect. So you know the difference between plus and minus and not. Okay. Plus is and, minus is not. Okay. So when we are saying plus contents mushroom plus contents steak, it means mushroom and steak both. Then return the document. Okay. So this is the example. Clear? Here you can say must plus, must not minus, and should is optional. Okay. So you can say something like this. If you want to write the query like this, you can say content mushrooms and content steak. So you have find file 3. File 3 have this. Okay, in file 3 I have mushrooms and I have steak. Okay, both. Here I have a streak. Okay, not mushrooms. Here I have nothing. Here I have only mushrooms. So when I say only mushrooms, you can say like this. You will get the data more. Okay, it's saying mushrooms or a stick. Then you will get file 1, 2 and 3. Okay, clear guys? Yes, here the field name is contents because right now we are indexing the file completely. Okay, okay, that is the default one. Okay, so that is the default one. Let me open the query parser demo for you. The class. Here you can see. Okay, so when you are adding the field, you are adding like this. Okay, in this class, we are creating the field like this. Okay, okay, Alvin, can you see this code? So that's what I am saying. Just walk through the code. Okay, so then you will get more comfortable on it. Okay? Or let me know if you stuck somewhere. Then I will. So go ahead and try these examples. Okay, pretty much most of it are common. Okay, and let me know if you have any queries or if you guys stuck somewhere. Perfect. Let me see what we have in lab 6. Okay, boosting. So it's a little bit let's test this after some time. Perfect. Shall we move? Perfect. Scoring and boosting. Scoring and boosting is one of the area or one of okay. What was the question, Alvin? You asked. You are talking about field name as a contents. How did you specify the name to be content? Yes, Alvin? Okay, okay, got it, got it. Yes, yes, yes. Sorry for that. I guess, okay, there is two questions in fact you guys are asking. Okay. Oh, for a business user. Okay, for a business, Alan's asking question for a business user that wants configure what price ranges are displayed on their website. Is there a easy UI for them to use configure some of these search features? Yes, Alvin. It's a pretty much easy in Solar. Okay, I'll show you. While covering the Solar, then I will show you it's all. I mean, right now I am showing the code because you guys are a Java professionals. That's why I am showing you the code. But when we move to the Solar, it's all about configurations. Okay, only configurations. You don't need to do anything. Some changes, define a schema. It's all about dashboards and through webs. That's it. So you can configure it directly through that. Okay, fine. So I was talking about scoring and boosting. So scoring and boosting is one of the module or one of the biggest part of Lucene or Solar, because of which this particular tool is widely used or famous. Okay, so is in one word or in one as a definition. Okay, scoring is a sorting of a documents by match quality. Okay, so by default it uses vector space model with term frequency inverse document frequency. So usually you will you will get this kind of a terminology on web or somewhere else. You will heard like this VSM and TF-IDF, vector space model and term frequency inverse document frequency. So these are the weights to score the documents. Okay, these things being used as a weights to score the documents. For an example, uh, you guys have a background in e-commerce. Okay, and you guys have gone through many sites, Amazon, eBay, or any other sites, right? Macy's. Okay, you buy products, you purchase a number of projects from there. You even give reviews to those products. Okay, any n number of users, customers give reviews to those products. So one of the example I am giving you. So let's say one user is looking for a Samsung phone with Android Jelly Bean 1.4 gigahertz processor, 2 gigs RAM and above. So these are the features he is selecting and executing the search. Now user is looking for what? Let me give you this with an example. First parameter, product name is equal to Samsung. Fine. Now processor type is equal to, let's say, Dual core, or let's say 1.4 GHz. Fine. RAM is equal to 2 gigs and camera is equal to 13 megapixel.
Fine. Okay guys, you guys can see my screen. So this is the filters user gone through. Okay, user selected. So these are the filter. Fine. So this query is being formed behind the scene. Okay, hit the Solr server or a Lucene API and fetch the results. So let's say from the inventory I am getting 150 documents in technical terms, or 150 Samsung phones with above criteria. Fine. Clear guys so far? Yes, no? Perfect. Now out of 150, this is what user is asking, right? Now out of 150, I have 50 products which has 3 or more star rating. Okay, and 60 products has 3 or less rating, I would say. Okay, now how much we have left? We have okay, 20 products with 1 star. Okay, now I have 20 products with 4 star rating. Okay, fine. Clear guys? Yes, no? Now this is the product. This is the results I am getting. So user is asking for these these details. I am getting 150 documents. Now how should I display it? So technically, I mean, if we have to do business, if we have to as a sales pitch or a marketing strategy, we should, how should we display? Okay, we have to display 10 product per page. How should we go ahead? You tell me guys. Alvin, Garfield, how should we go? Any idea? Any guesses? You're getting my questions, right? Alvin, Garfield, you guys on? So you guys are getting my question, right? So if you have to display these products online, okay, let's say 150 products, how you would like to display it? Okay, 10 products per page. How you would like to go ahead? Exactly, Alvin. So Alvin is saying highest rating products first, because we have to do some business, right? So how to go ahead with that, how to calculate these, how to rank these? So there are different criterias, right? Scoring, boosting. If you want to boost, let's say you are getting 150 products, okay, and you want to boost 10 products so that those 10 products and 20 products come at the top of it. Okay, you don't want to show the users first 10 products which is having the lowest rating. or the worst reviews, right? So these are some of the business scenario I was trying to explain. These are some of the business scenario, I mean, where you will find scoring and boosting pretty much relevant and pretty much used. I mean, they use different algorithms behind the scene, different business logic behind the scene to calculate the weights, to calculate the score of the documents. Okay. So scoring is the reason why Lucene is so popular. Scoring is very much dependent on the way documents are indexed. In Lucene, the objects we are scoring are documents and fields. Okay. Lucene uses various ranking algorithms to assign a score for each particular documents or fields. Okay. So I'll explain it. Vector space model. So this is the name of our algorithm actually. Lucene used behind the scene. So usually, I mean, we don't have to do much with this algorithm, but just for the explanation purpose, I am letting you guys know, because that is working behind the scene. We don't need to much worry about it, because that is calculated automatically. Okay. So VSN, a collection of documents each represented as a vector. A query also represented as a vector. Okay. We determine the documents of the collection with the highest vector space scores on the query. Okay. Typically, we seek these top documents in order by weights in decreasing order. Okay. For instance, many search engines use k is equal to 10 to retrieve and rank order the first page of the 10 best results. So this is one of the algorithms is used. Not exactly the same algorithms. They have refined it. That Google search engine. Okay, they have refined it and they are using it. So this is how actually they calculate the top 10 or top 20 or top 15 results per page. Okay, when we actually search. And it also it's, I mean, the Google one is it's a way ahead complex. Okay, we can have it simple, say, in a simple way as well for our web commerce application, but Google one is a very complex. It has many and many things. Okay. Scoring, similarity, weights, or score. Similarity is a metric defined over a set of documents where the idea of distance between them is based on the likeness of their resemblance or a semantic content. So how similar the documents with each other, how similar the fields are with each other. Okay, that is known as similarity in scoring. Also referred as documents weights or score, which would be used in the VSN. Okay, mathematical tools used to estimate the strength of the semantic relationship between the units of documents. Okay, this is the formula actually. TF and IDF, term frequency inverse document frequency. Okay, TF IDF is equal to TF multiplied by IDF. Okay, which is TFT is equal to number of times term T appears in a document. Okay, in a single documents, how many times a T's appear, and the total number of documents, total number of terms in the documents. Let's say I have the quick brown fox jump over the lazy dogs. Let's say one of the term, one of the example I would say, the complete document. And in that term, I'm talking about fox. Fox appears only once, right? And total number of terms in that document is, let's say, 10. Okay, 1 by 10. So it's like this. Okay, this is how it calculates term frequency. Okay, you are looking for a term T in that particular documents. Okay, and the number of term in that particular documents divided. Inverse document frequency. So inverse document frequency is the log of E, okay, multiplied by total number of documents divided by number of documents with the term T in it. That is inverse document frequency. Okay, so it's in fact Lucene internally use TF, IDF and VSM, but it's also tweak and do also certain other things as well now, and it's modifying it just for the better results and just for the better refinement of the
and results. Okay, this is how your scoring and boosting actually implemented behind the scene. This is the algorithm which is working. VSM, which includes TF-IDF. Okay, clear? You can dig deep if you want. It's a very common, I would say, very widely used algorithm, vector space model and TF-IDF. You will get it almost anywhere you want. Okay, so basically it's used in search engine for searching actually. Okay guys, any questions? Okay, score boosting. Documents weight or score can be changed from default, which is called boosting. So first thing is that you can create or you can assign a score while indexing as well, or you can boost that particular score at the time of query as well. So for an example, you have indexed all the, okay, so example, let's take the example one more time. So let's take the publishing example, books example, right? So you are, let's say you are working for some publishing industry, okay? And you are creating indexes for books so that a user can search books with title easily or with author name easily. Okay, so you have realized that, I mean, most of the time users search uh, the books with title. Okay, so what you did, you create the, you increase or you score or you score, you, I mean, you increase the score of title field more in compared to other fields. Okay, so that it can be more relevant, or it can be searched faster in compared to other fields. Fine, so that is called index time boosting. Okay, index time boosting, while doing indexing, you are calling that particular field and you are calling the method set boost. Okay, and you are assigning the float value or for that, and that float value is higher than other fields, let's say author, publisher, or any other field. Okay, this is how you do index time boosting. Okay, now your data being indexed and your title is being boosted more in compared to other fields, author, price, or any other field. Okay, now during query, you know that you are getting the boosted result in terms of title, but some of the users looking for author more now. Okay, so for an example, you have allocated 3.0 3.0 for title, and 2.0 is default for author. Okay, not author is 2.0. Now you see that you want to boost it more than the title. Then what you can do, at query time you say query dot set boost, okay, for that particular field, and you can boost with 4.0. So that will give relevance more in compared to title. You guys are getting right what I'm trying to say? So this is how your index time boosting or query time boosting works actually behind the scene. Okay, so initially you can index it and you can set the value of the boost for that particular field, index it, and even you can change it at the time of query using that particular method. Perfect, this is the example. And this is the example of query. This is the example while you are indexing and you are adding the document, and this is the example how you are boosting during the query. Okay, let's see some labs.
Here is the boosting. M26, right? Okay. No. Now the class which we are using boost examples.java. Let me open the class for you as well, because we are directly using classes here. So this is the documents which is getting indexed here in Java file. Okay. So let me show you the example. Okay. Boost time index false. Search produce 6 hits like this. Okay. Some of the vehicle names, country, color, price, and the type of the vehicle. Okay. Now I am saying boost index true. Then it will show you a different result set. Okay. When you see the result set here, it will also show you the scores as well. Okay. If you see here, default similarity is there, item type SUV in one, and if you see, it will show you the field weight as well. It will show you the term frequency, how it is getting calculated. Term frequency is 1. Okay. And IDF is 0.845 and field norm is equal to 2.0. If you want to see all the metadata out of it, then you can get the metadata out of it as well. Okay, clear? So this is you can get from your lab, and it will show you the, okay, 1 second, it will show you how the query is working as well. I mean, this is the index time, and you can go for the query boost example as well. Okay, clear guys? And I will show you how it works behind the scene as well with the tool as well. Do you guys hear about anytime you heard about Luke, L-U-C-K, sorry, L-U-K-E, Luke? You know about this tool? Okay, so maybe at the end I will show you how actually Luke works, and you can that is an open source. You can download it and you just to see how your index being stored. and what is the score and all. I mean, how actually it look likes. I mean, when it stores as a flat file, because that is in a non-readable format. You cannot access it directly, okay, but only through some tool, and how it is stored, okay. So I'll show you at the end, okay. So let me see some other lab as well, okay. What is this? It's highlighter. So let's talk after this. So any questions, guys, so far? Any questions? Let's cover a little bit of advanced topic as well, okay. So mainly, I mean, we will be extensively covering this in a Solar classes, okay, because that is the main intent, and actually you guys mainly using the Solar in your e-commerce applications, right, guys? You guys are using Solar, right? Okay. So okay, you are intended to use maybe in the future. Alvin, what about you? Yeah. Okay. Highlight query terms. Okay. Highlight query terms. Let me show you one of the example. And the Google is the best to show you. Any idea about highlight, guys? Highlighting query terms. This feature, what it does. I mean, without explaining first, I will give you the first-hand information with Google. Okay. Any idea, guys? Alvin, Garfield? Exactly, Garfield. You're right. So let's say you are searching Lucene, okay? And when you search it, you will see the end results, and in the end result, you will see all the search results you are getting. Lucene is in bold. See, it's in bold. See, this is bold. This is again bold. Bold. Okay. Here it is bold. Highlighted. So highlighted in bold. Okay. Whatever you are looking for, it is getting bold. Okay. You're getting. See, even this is getting bold. Where you will see that particular term, you will get it bold, right? So this is the work of highlighter. Okay, this is how highlighter work. Okay, the highlight package contains classes to provide keyword in context, features typically used to highlight search terms in the text of results pages. Okay, so the highlighter class is the central component and can be used to extract the most interesting sections of a piece of the text and highlight them with the help of fragment scorer and formatter class. So let me tell you what happened behind the scene. Okay, so let's say you are talking about Java. Okay, okay, yeah, let's say you are searching Edureka. Okay, now it's going to the document, it will look into the documents. Okay, document. Okay, let's say name is equal to Apache Edureka classes. Okay, this is document 1, 2, 3, and Apache Hadoop
Edureka classes. Edureka classes for machine learning. Okay, so let's say you are looking for to search for Edureka. Now, as an end result, you will get a JSON response, let's say, or any other response you want to see. Okay, something like this. Okay, you will get something like this. Okay, so when you will try to display it, it will display it something, let's say it transform the result set. Okay, and when you transform the result set and it will return back as a response, it will become something like this. And as an highlighter, you are saying I am using highlighter here, highlighter package. Okay, and replacing or surround with, let's say, T. Okay, you want your use highlighter package. Okay, and you want to surround the search term with bold. Okay, so end result will be something like this. Okay, it will become something like this. So when it will render on the page, it will make it bold. Or if you want to replace it with, let's say, EM, or let's say LI. Okay, whatever you want. Okay, you can use the prefix and postfix as per your business requirement for the highlighter package. Okay guys, this is how your highlighter package works. This is how you highlight the term. Okay, perfect. Faceting, you have seen many example here in faceting. Let's say Amazon, you have looking for books. Okay, and while searching for books, you get you go into that section, book section, and you'll see so many facets create, and the facet title is like language, price, binding, author, title, or whatever. You can have any number of facet types you want. Okay, so these are the facets actually. So when you click on any of this facet, let's say you want all the books in English, you click on English you go into that facet language and click on English. Then what it does, it will filter all the results and fetch all the documents or all the books which is written in English. Okay, or you want all the books where author name is Herbert Schild. Okay, you can create a facet on author name as well. So those facet types or facet names will be decided as per the business requirement. Okay, what all business requirement you have and how you want to design that your application. Okay, so accordingly we design or we assign the facets type, different facets type. Okay guys, facets clear? Perfect. So this is how your faceting actually works. In faceted search, in addition to the standard set of search results, we also get the facet results, which are a list of subcategories for certain categories. Okay, so even you can create a facets of facets as well. Okay, grouping. How to group? Okay, how to group? You want to group the documents on the basis of language. You group all the English book. You group all the books where price started with $200 to $500. You group all the books which is authored by Herbert Schild. Okay, so this is group. Clear? When we use any of the particular facet and click on it, that will become a group. Okay, author field, book price range, title, or language. Okay, okay guys, yes, no? Okay, so just one thing I would like to uh, share with you guys. Okay, between you guys would have asked the question, I mean, what is the difference between facets and group then? So the main difference of facets and group is that when you create facet, okay, facet is this, okay, when you create facet, so it's bit faster because facet returns the number. Let's say it only returns the number. Let's say it says that there is only 1521 English books. There is only 580 French book. There is only 200 Russian book or Russian language book. Are you getting my point? So it's only written the number of the documents in Facet. Clear, guys? In Facets, so Facets is little bit faster. So when it is your first page, use Facet. It will load faster and it will tell end user that you will have this much of book for English language. This you have this much of book for this particular author. Okay, okay, guys. So whereas in join, in group, when you click on the group, you says that I want all the English, I want all the Java book written in English. Okay, so what it does, it will hit the indexes and it will fetch all the documents, actual documents. Let's say 500 books or 500 documents and load it. Okay, so it will actually return all the books related to that particular query, which is it will group all the books written in English language and for Java. Okay, example. So this is the difference between facets and group. Clear? Perfect. Joins. As we have seen joins in RDBMS as well, we have joins in uh, Lucene as well. Lucene supports index time and query time joins. Okay, index time joins are like helps while searching. Okay, where join documents are indexed as a single documents block using index.writer.add documents. This is a useful for any normalized content, XML documents or database tables, or uh, you want that, I mean, there are certain documents which should be joined in any case, and that should be searched or that should be displayed together. For an example, the series of books, let's say Lord of the Rings series, let's say Hobbit series, let's say uh, any other book series, and you want that to be indexed together, you can do that. That is index time joining. Okay, so when you index in this way, the documents in your index are divided into parent and child documents. Okay, parent documents, let's say your first version of the book. Okay, first volume of the book, and childs will be like 2 3. Volume 1 is the parent and volume 2 3 and 4 is your child documents. So this is, if you want, I mean, that is again business requirement. If you want to index time join, you can use index time join like this. Okay, query time join. Query time join like somebody is purchasing something. Okay, somebody is purchasing Samsung mobile phone. Okay, so Samsung, while purchasing Samsung mobile phone, you have seen so many options as well they provided. While Samsung mobile phone, you are purchasing Samsung mobile phone, they are giving you some hand free or Bluetooth headset, or they provide you combo offers, right? Have you gone through those? You have seen, right, in e-commerce website, Alvin, Garfield. So these kind of a thing, these are some of the example where which use query time joins. Okay, while purchasing, while adding to the cart, you are getting an offer. Okay, for coupons or for something else. So these are query time joins. Okay, while you're querying, it is joining some additional things as a promotional offer or whatever, right? So those are query time joins. Clear? Yes, no? Perfect. Any questions so far? Perfect. Let's see what we have in a lab. We have highlighter lab. So let's say quickly go through the lab 7. Lab 7 is highlighter demo. Okay. Okay. Let's say I am highlighting the stick. Stick is a search term. I want to highlight it. How it is done? Let's see. So if you see here, it will a big one. But if you look for a stick here, where is a stick? Okay. Stick. Highlighting match. BR. It is giving you all so many details. Okay. But it should also give me okay. I'm not able to find the stick here. BR result of. So I'm looking for some before and after tag, actually which you can see in a better way in Solar. So let me display this thing in Solar classes because I am not able to see it here. If you see here, it is giving you highlighting HTML, UL, okay, UL and LI. It is providing you UL and LI here. You guys can see here, right? It's providing the data in the form of UL and LI tag, right? So this you can replace with bold or any other term you want, so that it can be directly injected in your UI, and it can be bold or highlighted as you want. Okay, so this is a very small example of highlighter. Okay. Add a class. Okay, you want to open the class, right? Okay, what do you mean by class? Java class you are talking? Yes. I mean, as that's what I'm saying. Definitely, I mean, you can do that as long as that is an static content, right? I will show you in Apache class, Solar classes as well. So as long as it's an static content, let's say I've shown you the example like this, right? So maybe if you want to do, let's say you say class is equal to uh, my CSS class like this. You can do that. Because ultimately that will be getting those particular term will be getting injected or ingested in your HTML UI page. You have to handle it at the UI layer. So your UI team, or if you are yourself handling the UI, then you should know that what is coming. Okay. so that you can handle it. But it will be a kind of a tightly coupled code if you do this. So we usually avoid these kind of things. Okay, you can do the classes, but it will be like you are adding the class name in your different API, which is only for searching and indexing, right? So it will be a kind of a tightly coupled code. I mean, that will be dependent on some other libraries, right? Where is your web application lying in somewhere else? So I mean, that is depend how you actually design the code. You can do it, but I won't suggest it. Here is the facets example. Let's do some facet example as well. So here you can see, I mean, it's a little bit tricky one, but because that is a command line, let me show you here somewhere. If you see here, this was the result. Okay. Now you can see ID, title, book category, authors. Okay. So these are the facets: book category, comedy, drama, okay, tragedy, authors, Jean, Alex, Mark, Gerald. So this way you can create the facets. Okay. This is how you create the facets. But the best way to see these example, these advanced form is Solr. You will bang on, you will see in the HTML form or in the dashboard kind of a thing how it is actually getting created, how your facet is getting created, because it is a command line, right? So it's a little bit tricky. Okay? So you can create a facet on the basis of book category like comedy, drama, or if you want to create facet on the basis of author name, you can do that. So likewise. Here guys, any questions so far? Perfect. So let's see. There won't be any app. Spatial search. I guess you have used it many a time. This thing. While doing searches for locations. So while landing on New York, you are looking for a hotel near about JFK airport, right? Okay, so nearby hotel. So you search that and it will give you this kind of a structure. Hotels, let's say hotels near JFK. As soon as you search it, so even you can see here, even okay, okay, Expedia airport.
Okay, and when you click on maps, you will get something this. You guys can see this, right? So usually you can see the dots here, red dots, some big dots. And if you see some other applications, let's say Expedia.com, travelguru.com, or some other website which deals with hotels and restaurants or locations, or the best is store locators. Macy's is store locators. Go ahead and check for the Macy's store locator. Okay, so what it does, it actually create a polygon kind of a structure through maps, okay, around the location you are looking. Okay, so that is, again, these are some of the business domain or industry where we go for what I can say, where we go for where we use Apache Solr as a search libraries. Okay, what we does here, we simply use as a geo databases. Okay, and we store location information in form of latitude, longitudes, nearest locations, and some other metadata. Okay, and we simply store it. We look for that particular term in the query database in our indexes, and will identify all the related latitude, longitudes, and draw the polygons out of it. Okay, so it will listed all the related hotels, or if you're looking for schools, or if you're looking for something else. So this is how actually spatial search or spatial search works along with your Lucene or Solr. Okay, so the hotel search application or any other search applications is works on that. Okay, so one of the example you can see here, they are trying to draw some polygon kind of a structure here. Okay, perfect. So any question on that, guys? Perfect. Apache Tika, I mean, you heard of so many open source libraries and open source frameworks by Apache. One of the frameworks is Apache Tika. So Apache Tika is a framework or a toolkit, you can say, which detects and extracts metadata and text content from various documents, rich documents or rich files, I would say, like PPT, CSV, PDF, Word documents, or many. It supports many other documents. So why we are discussing this? Because uh, while indexing or while getting data, we used to get data in the form of XMLs. Okay, we used to get data in the form of flat files. Even sometimes we used to get data in the forms of rich file as well. For an example, job site. Okay, where you look for job. Okay, where you upload your profiles or resumes. Okay, in PDF or documents. So those business also using Apache Solr or Lucene for searching, because they have millions and millions of database for profiles. Okay, they have millions of profiles uploaded. Okay, so they have to index those profiles so that it can be easily searched by by the job seeker or by the job provider, both. Clear, guys? Yes, no? So we have a different data sources for Apache Solr and Lucene, which we use to index the data. One of is flat files in the form of XML, TXT, log, Excel, and then some rich file, PPT, PDF, CSV, XMLs, XSLTs, and Excel files, Microsoft Word files, and many other files, right? Even the zip files as well, zip and tar files. Okay. Then we have a data source as a crawling. We used to crawl big website to get the data, like Amazon. Okay, and different other sites. We used to crawl those websites and get the data and index it. We used to
interact with the databases as well to get the data, RDMS, to connect to MySQL, Oracle, or any other database to index it. So these are certain data sources we have to index the data. So some of the rich files like PPT and PDF and doc, so for that we use Apache Tika library to index it. Okay, clear? Perfect. So these are some of the Apache Tika support. I mean, in terms of files, Excel, Word, PowerPoint, Microsoft Office, Adobe, all the files, PDF, RTF, HTML, XML, zip archive, tar archives, and MP3, Java files, many. Images, I mean, when we talk images, it's metadata only. Okay, Adobe Flash, MIDI files, so many files it's supported. Okay, so this is one of the feature in Edureka Annie. So Annie pop up now and then, I mean, like this, and it will ask some questions. So any one of you using stop analyzer, you can stop bad words from indexing and search. Is it true or false? Perfect. True. What is used to search documents matching age ranges between 30 to 40 years? Numeric range, wildcard, or prefix? Perfect. You're right. Numeric range. Apache Tika, which we have just gone through, is used for searching rich documents, searching internet, searching Wikipedia. ABC. Perfect. Exactly. You guys are right. So let's see what is 8. So 8, it's pretty straightforward in Spatial demo class, which we simply hit and which will provide the related metadata in the form of JSON. Okay, I could not find Spatial demo. Okay, so there is some okay space. Can I see Spatial method? Class not found exceptions. Prefix Spatial. Okay, might be some jar related issue. Okay, saying spatial prefix tree. Spatial prefix tree. Spatial prefix tree. For Lucene spatial 5.3.1. Okay. Spatial prefix tree. 4.1. 15 spatial 5.3.1. Okay. I need a jar file and professional repository Lucene for Apache. Lucene. Let me try one more time.
Same class from Spatial 4J shape. Okay, some of the I guess some jar files are missing, I guess. Com Spatial 4J. Com Spatial 4J. Com Spatial. No such field error. Latest Spatial demo. Let me check. Okay, I'm coming to your question. Okay, so let me fix this, I guess. Then I will show to you guys this Spatial one because it has some glitches. Okay, I need first of all fix this, then we'll show it. Okay, guys. So there is a question from Alvin. When we run these queries, what are the objects written? Is it JSON, XML? So it's up to us. The response can be configured. Okay, you can, if you want, you can have it in a JSON. If you want, you can have it in XML. Even if you want, you can have it in an XSLT as well. Okay, depending on your requirements, you can configure it, and it's highly configurable in Solr. The response thing, I'll show you in the Solr classes. Okay, guys, any other questions? Perfect. So that's all. That's all for today class. So assignments: explore different kind of analyzers, tokenizers, filters. Okay, as a homework. Create multiple text file and try to index it. Okay. Try with different type of query parsers, query ranges, query syntax. Okay. Use boosting. Okay. Go through your Java source code. It will give you more insight how it is working behind the scene. If you are a Java guy, it will help you. Otherwise, it's not mandatory. Okay. Run the labs, all the labs by your own as well. Okay. Build and try to build and search complex documents as well. Okay. Okay, guys. So agenda for the next class will be in introduction with Solr. Solr versus database, how to install and run the Solr, admin UI, quick to dashboard, what is the architecture of Solr, how or what we do with Solr schema, okay, how to create it, what are the fields, okay. So these are the things we will be covering in the next classes, okay, next two classes next week. Okay, guys, any questions before we wrap up things? Alvin, you good? Alvin? Perfect. So thank you guys. Thanks for your time. And please don't forget to attend the session next week. If you have any questions, just simply go ahead. I provide you the support information in your LMS. Okay. Create a ticket. It will redirect it to me. Okay. And anyways, we'll be meeting again next week. You can ask me the questions if you have. Okay. So please provide your feedback after this class. Okay. So that we can improve if there is any gaps. So guys, so just please provide your inputs, and thanks for your time guys, and we'll see you next week. Thank you.